Web services are based on the HTTP protocol, and HTTP is based on a request response architecture. Clients, mostly using browsers, send messages to HTTP servers, which generate messages that are sent back to the browsers, right? So then the messages sent to HTTP servers are called requests. And you're probably going to guess the messages actually coming back from the servers or generated by the servers are called responses. Now, in practice, servers and browsers sometimes don't communicate directly, right? So there could be one or more proxies in between that connection. Now, a connection is often also defined as a virtual circuit. Let's go over the structure of HTTP messages, right? So HTTP messages, both the requests and the responses, have a structure that consists of a block of lines comprising the message headers, also followed by an empty line, and then by the message body. However, HTTP messages are not designed for human consumption, and they actually have to be expressive enough to control HTTP server, requests, browsers, and proxies. Now, when HTTP servers and browsers communicate with each other, they perform interactions based on headers as well as the body content. Now, let's take a look at a very simple example. Right here, we're going to load a static web page residing on a web server, and we actually launched a web browser and went to example.com. Now, the page is actually displayed in the browser as you can expect, but let's go and look at all the nitty-gritty details of that HTTP transaction. So for that, we're going to use Wireshark, which is a packet sniffer. Now, here you see the HTTP request, and the request has the following structure. You have the method, which represents one of the several supported request methods. In this example, is an HTTP GET, but the methods can be things like head, which is basically the same as a GET, but returns only the HTTP headers and no document body. You also have the put method, which uploads a representation of the specified URI, right? You also have the delete method that deletes the specified resource. You also have options, which returns the HTTP methods that the servers support. And then you have connect, which converts the request connection to a transparent TCP/IP tunnel. Now, some of these, as you can probably imagine, are not secure. So as we go through this course, we're going to actually explore some of these methods and the security implications for those specific methods, right? And then mostly what you will expect is either an HTTP post, right, or an HTTP GET, right? Now let's go back to Wireshark, and here you see the URI and the path to resource field, which represents the path portion of the requested URL. You also see the version number, right? So the request version number, which specifies the HTTP version that is used by the client. You also see the user agent, which in this case is Firefox because we were using the Firefox browser in Kali Linux. Then you see several other fields like the accept language, the accept encoding, and several others. Then the server, after receiving the request, tries to generate a response. Now the HTTP response has a few items: the request version, a 3-digit status code, and a brief human-readable explanation of the status code. Then down below, you see the text data, which is the HTML code coming back from the server and displaying the website contents. Now, I suggest that you become familiar with the status codes of the HTTP messages because they're very important, just like the methods, for security, right? Now, the W3 Schools website has a very good explanation of these messages, right? In short, messages in the 100 range are informational messages. Messages in the 200 range are related to successful transactions. The messages in the 300 range are related to HTTP redirections. Messages in the 400 range are related to client errors, and messages in the 500 range are related to server errors, right? Now, in the next lesson, we will go over session management and cookies.